We are looking at Unit 8 review assignment. This covers Chapter 8, which is our quadrilaterals chapter. So we start off with our first problem. We need to find the value of x, and we're going to see a lot on this first page. It's dealing with interior and exterior angles of polygons. So in our first one, we have a hexagon or a pentagon. This has 5 angles or 5 sides, and our rule to find the total for its angles is to take the number of sides or the number of angles, subtract 2 and multiply it by 180, or n minus 2 times 180. So that's going to give us 3 times 180, or a total of 540. So all 5 of these angles add up to 540. We're looking for our missing one. Well, we know we have 120. We know we have 90, 90, 90, and x as our values. If I combine all of these, the ones that I know, I get 270 from the 90s, 120 with that gives me 390. I then subtract that and I'm left with 150 degrees for x. So if all of it is 540 and I know these values, x shall be 150. The next value, it has 4 sides. It is a quadrilateral. Our total for a quadrilateral is 360 degrees. And that's equal to the sum of its angles, 8x plus 1, plus 5x minus 4, plus 95, plus 73. Now, I combine the ones that I know, or combine the whole numbers I have, I should say. I have 95 and 73, which gives me 168, plus 1 is 169, minus 4 is 165. So I have 8x plus 5x plus 165. I can combine my x terms. I have 360 equals 13x plus 165. I now subtract 360, or 360 minus 165, so I'm subtracting over 165. I get 195 equals 13x. I then divide 195 by 13, and I get 15. So x in this case would be 15, or A. Number 3, it wants to know the total for the exterior angles. Now, even though it's an octagon, our rule is whatever, doesn't matter how many sides we have, the exterior angle is always, the exterior angle total, we should say, is always 360. Our answer is C. In number 4, determine the measure of each interior angle of a regular-sided polygon with 9 sides. Here we're going to use what we talked about earlier, n minus 2 times 180 to find the total. Then the measure of each interior angle of the regular polygon will be the same. So we're going to take that total and divide by the number of angles we have. So 9 minus 2 times 180 gives us 7 times 180, which is 1260. I then take 1260 and divide it by 9, because 1260 is the total of all my angles. I have 9 angles total, so to find what they are, I would divide, and we get 140 degrees. In number 5, I have each exterior angle of a regular polygon, so the same idea as number 4, but now we have 12 sides. Now, each exterior angle, well, the total for exteriors are always 360, like we saw in number 3. If I have 12 of them, 12 exterior angles, and they're all equal because it's regular, I divide 360 by 12, and I get 30 degrees. In number 6, the measure of an interior angle of a polygon, of a regular polygon, is 162 degrees. How many sides does the polygon have? So in this case, we can really look at it 2 ways. So I have some polygon that kind of goes off, however it may finish, and I know that interior angle is 162. Now, I have, we could say, n of those angles at 162 degrees. Now, if I have n of those angles, and I knew how to find the total, which is n minus 2 times 180, I can set those two values equal. Now I can solve for n, and that gives me 180n minus 360. I then subtract over the 180n from 162. I get negative 18n equals negative 360. And 360 divided by 18 is 20 for n. Now, I divided a negative by a negative, so it should be positive. So I found n is 20, or 20 sides. 20gon is what we could call it. But I said there's two ways we could find that. And although we found it this way, it was a little more calculation than we needed. There's actually an easier way to do this. Now, if I know that each interior angle is 162, I also know that each exterior angle is 18 degrees. That's because the interior and exterior angles are a linear pair, or they're supplementary. So, I can now take this idea that I have 360 degrees, and I have 18 degrees of n angles. So, however many I have, I would multiply by 18 to get my total of 360. Or in other words, 360 divided by 18 equals my number of sides. And if I divide 360 by 18, I get 20, which matches my original answer. Either way works. The exterior was a little nicer in calculating, but again, you could use either one. We kind of carry the idea of that relationship between interior and exterior into number 7. Here I can solve for the interior angles, find this angle, and then find its supplement, which would be the exterior, or x. So let's call this y. That's what we're going to solve for first. Now, I have 6 angles, or 6 sides, because it's a hexagon. So 6 times 2, or 6 minus 2 times 180, gives me 4 times 180, or 720. 720 equals 100 plus 140 plus 100 plus 100 plus 140 plus y. Now, I combine all of those. I'm really solving for y here. I have 3 100s, so 300. 2 140s, that's 280. And that's just by grouping them. Then I have 580 plus y equals 720. I then subtract and find that y is 140. So that's this angle here. Not quite x yet, that's the interior. So if the interior is 140, the exterior or supplement of that would be 180 minus 140, or 40 degrees. So we had to use interior in that case to get to the actual exterior. Okay. Next we're looking at number 8. In number 8 we have the sum of the interior angles of a polygon equals 3,780. How many sides does it have? So, we know the total is 3,780. The rule we have to find the total of the angles is n minus 2 times 180. So that allows us now to solve for n, which again is the number of sides. So the way I'm going to solve is I'm going to first divide both sides by 180. If I divide 3,780 by 180, I get 21. So 21 equals n minus 2. I now add 2 to both sides. I have some problems today. And I get 23. So it's a 23-sided polygon. We call it a 23gon and go with answer A. Number 9, what is the measure of each interior angle of a regular hexagon? We can find the total. And whatever the total will be, we're going to divide that by the number of angles we have in a hexagon, or 6, and that'll give us each interior angle. So 6 minus 2 times 180 gives me 4 times 180, or 720. And my total is 720. I'm going to divide that by the number of angles I have, or 6, and I find it's 120 degrees. Now in number 10, what are the values of the variables in the given parallelogram? If we look first, we can match up opposite angles are the same and consecutive angles are supplementary. So in that regard, we know that 6x minus 8 is equal to 4x plus 6. So I can set those two equal, solve for x. If I subtract 4x from both sides, I get 2x minus 8 equals 6. Add 8 to both sides, 2x equals 14. Therefore, x is 7, which gives me these two possibilities. Now I need to solve for y. Well, I don't know what the opposite angle of y, or this 2y plus 16 is. I do know angles next to each other are supplementary, but looking at it right now, that leaves me with an x and y in our equation. But we know x. We can take x and we can plug it in. 6 times 7 is 42, minus 8 is 34. 4 times 7 is 28, plus 6 is also 34. I did both of them just to make sure my answer for x fits. They should be the same. But more importantly now, I know that 34 plus 2y plus 16 equals 180. Well, 34 and 16 is 50. I then subtract 50 from 180 and I get 130. Divide by 2 and y is 65, which gives me answer B. Number 11, I have that FH is 30, so this whole length is 30, and I need to find FK. Now they gave me this 12 here for KJ, and I have 30 for the entire length. Since this is a parallelogram, opposite sides are parallel, I know that diagonals bisect each other. So I know that this segment and this segment are the same, as well as these two segments. Now the fact it bisects, that tells me K is in the middle of this diagonal. So in fact, FK will be 15, because KH is 15, and they add up to be 30. That 12 is really there as a distractor. Yeah, the 12 would go up here, but that does not apply to the part we're looking for. And number 12, we have a rhombus. And what we're going to use here for a rhombus, yes, we know that all sides are congruent, but also we know that diagonals bisect opposite angles. So we know that these angles are the same, as well as these angles. More importantly, I can then break off a triangle here, where I have 110 and congruent angles with x, which I can make both of them x. Well, 180 equals 110 plus x, or 180 equals 110 plus 2x. I subtract 110 and get 70 equals 2x, so x is 35 degrees. And again, that is because the diagonals bisect opposite angles in a rhombus. For 13, we have a rhombus again, and we need to figure out which statement is true. Now, for a rhombus, we know a few things. We know that all the sides are congruent. We know that the diagonals are perpendicular. And we know that the diagonals bisect opposite angles. So we can mark these. Now we need to keep in mind here it is also a parallelogram, so any of those properties also work. But the fact they're telling us it's a rhombus, we're probably going to use one of those properties. So we go through. PSR is a right angle. PSR is this angle right at S. We know it's bisected. We know it's congruent to Q, but we do not know if it's a right angle. In fact, if it was a right angle, this would be a rectangle. So that's out. PR is congruent to QS. PR and QS are diagonals. We do not know they're congruent. If in fact they were congruent, it would be a rectangle. So that's out. PQR, QRS are angles that are next to each other. They're consecutive. If those were the same, they would be congruent. And if they were congruent, again, it would be a rectangle. Brings us to D. PQ, QR. Those are sides of the rhombus. All four sides are the same in the rhombus, so we're going to go with answer D. The rest are really what's required for a rectangle.
The following teachers have not tested a portion or all of their attendance. Leah Bogdan, Rick Hammond, John Jones, Daryl Miller, Kevin Miller, Jason Mulligan. I don't have fourth period for Esmeralda Wicca and Daisy Schuyler. Please post your attendance now. Thank you.
On 14, we're trying to find which statement is true. Now, we can kind of draw out a diagram we've talked about in class for this. We start with a quadrilateral, And from a quadrilateral, we have a trapezoid, a kite, and a parallelogram. From a parallelogram, we have a rectangle and a rhombus, and then those two combine to make a square. Now, I did abbreviate here, and you can go back to the chart we went over, but that's the process we're looking at. So, all quadrilaterals are rectangles. Well, I have all quadrilaterals up here, and I can actually break apart quadrilaterals to go into this group, but it won't necessarily go all the way down to a rectangle. All rectangles are quadrilaterals is saying that a rectangle will fit into the quadrilateral group. And if we look at it at first, a rectangle is off a branch of the quadrilaterals. So that may be an option. All rectangles are squares. So again, we're looking at rectangles and squares. Well, in fact, a square is a special case of a rectangle, so that doesn't work. And all quadrilaterals are squares. Well, even if we just look at that, all four-sided shapes are not squares because we have plenty of examples of four-sided shapes that are not squares. So, going back to the second one, all rectangles are quadrilaterals. A rectangle fits into the quadrilateral family. It's actually a part of the parallelogram family, so that helps us see that B is our correct answer. Keep in mind also from this diagram, as we work our way down, each shape above a given shape is what it fits into. A parallelogram is a quadrilateral. A rhombus is a parallelogram and a quadrilateral. A square is a rhombus, parallelogram, and a quadrilateral. Now, they don't jump across. A parallelogram isn't a kite or a trapezoid, but it always goes back up and reverses the process. As we go to our next page, I told you you could skip number 15. That involves systems of equations, and we're not going to have to address that for the test, so we can worry about that for another time. Brings us to number 16. So in our diagram, we have the measure of angle 1 is 9x, and we have the measure of angle 2 is x plus y. So we need to find the value of x and y. Well, noticing just how it's set up, we're probably going to find x first, and then we could substitute it in to find y. But if we look at what we're given here, we notice all four sides are the same. If all four sides are the same or congruent, we have a rhombus, which furthermore tells us the diagonals are perpendicular. In that case, each of these angles has a total of 90 degrees. So 9x equals 90, so x is 10, and x plus y equals 90, so we could put it into 10 plus y equals 90, and we find that y equals 80. So x is 10, y is 80. On number 17, we're looking at an isosceles trapezoid, so let's sketch this one out. J and M are congruent base angles, so let's put those here. Oops, J and M. And let's label what we know. 18x plus 5, 14x plus 15, and 17x plus 10. So we need to determine the value of x. Now in an isosceles trapezoid, first of all, in any trapezoid, we would know that those two angles, the 14x plus 15 and the 18x plus 5, are supplementary, because J and K would be supplementary angles. They're really consecutive interior angles if we're looking at parallel lines. We also know that these two angles, the J and M, are congruent because base angles are congruent. So you could either do 14x plus 15 plus 18x plus 5 equals 180, and that's using the fact they're supplementary, or you could use 18x plus 5 equals 17x plus 10 because base angles are congruent. Now, just looking at these, the second one looks a little nicer to solve. If I subtract over the 17x, I get x plus 5 equals 10. Subtract the 5, I get x equals 5. There's our answer D. Move to 18. Perimeter of a square, MNOP, is 72 inches. We know that NO is 2x plus 6. We need to find x. Well, in a square, I know all my sides are the same. So really, to find the perimeter, I would add all four sides, or since they're all the same, 72 equals 4 times one of my side lengths, which is 2x plus 6. Now, from here I could distribute that 4, Or I could also divide the 72 by 4, essentially divide both sides by 4. I'm going to do that just because it gives me smaller numbers. So 18 equals 2x plus 6. That becomes 12 equals 2x. Therefore, x is 6. For 19, this is going to be a mid-segment problem. And our mid-segment, hi, is 5x plus 2. That is equal to 4x plus 1 plus 27 divided by 2. I can simplify this to make it 4x plus 28 divided by 2. We really have two options here. I can multiply over the 2 to this side and multiply that quantity by 2, or I could take half of these values on the right side. And since they're both even, I'm just going to do that in this case. But realize either way would work. I have 2x plus 14. Ran out of room here, so let's go over here. We're going to subtract. Let's see. It doesn't look like we'll need it for this next problem. So we're going to put it down here. 5x plus 2 equals 2x plus 14. Subtract the 2x. I get 3x plus 2 equals 14. 3x equals 12, so x is 4. Now, we have to be careful here. What are they asking us for? They're asking us for KL. So if x is 4, KL, we substitute in the 4 for it, for x, and we get that it is in fact 16 plus 1, or 17. But always be careful on this one. Make sure you read what they're asking for. You don't want to find x and then forget to plug it back in and really get the wrong answer when you did all the correct work up to that point. Okay, number 20, which quadrilateral has two pairs of consecutive congruent sides but opposite sides are not congruent? So if I draw just a general quadrilateral, two pairs of consecutive congruent sides, so that could be those two and these two, but opposite sides are not congruent. It means I'm going to make it look like that. Now we only have one shape that works, and that would be within a kite. A kite has two pairs of consecutive congruent sides, but again, those opposite sides are not congruent. Goes back to our definition for a kite, so it would be A. Let's go to 21 now. We need the most specific name for our quadrilateral. If we look at what we have, since these are both right angles, that means that these two sides, these left and right sides, are perpendicular to this one. If they're both perpendicular to the same, that means they're parallel. And that gives me one set of parallel sides, which means we have a trapezoid. 22, you know what, 22 is also one we could skip. That looks at systems of equations. Again, we do not need to worry about that part, which gets us down to 24. For 24, we're going to solve for n, we're going to solve for x. If we look at the list here, it looks like we're going to do n first. So n would be a midsegment, or n is a part of the midsegment, EF. So 3n minus 4 equals 1/2 10 plus 36. That gives me 3n minus 4 equals 1/2 of 46, 1/2 times 46. 3n minus 4 equals 23. 3n equals 27, so n is 9. Now if n is 9, we have to substitute that back in to find EF. So 3 times 9 minus 4 gives us 27 minus 4, or 23. For x, we have to look at the fact we have these two angles here, and this is a trapezoid. Isosceles or not, and we know that those two angles in this case are supplementary. 3x plus 2 plus 2x minus 17 equals 180. I combine the x's and I get 5x minus 15 equals 180. 5x equals 195. Oops, make that a 5. If I divide by both sides by 5, that leaves me with x is 39. I now need to find ADC, which is the angle over here. But since it was isosceles, this is the same angle as this one, so I can just substitute in 39 to 2x minus 17. 2 times 39 is 78. Minus 17 gives me 61 degrees. Okay, we're going to skip 25. Now that brings us to 26. Last page. Okay, ABCD is a rectangle with perimeter of 96 meters. We need to find the following information. So it starts off, we have a rectangle and it wants to look at angles. So let's address those first. Now, in a rectangle, I know all my angles are the same. I also have, even before I start looking at which angles I need, I also know that diagonals bisect each other because it's a parallelogram, but they're also congruent because it is a rectangle. So if I do that, I actually see now that I have 4 triangles here where the opposite ones, the ones that are attached by a vertical angle, are isosceles congruent triangles. So that's going to be something that helps us. So we're going to look for DBC first. So I have an isosceles triangle up here with ABE. So if this is 28, so is this one. Then to find this angle, DBC, well, that's just the complement of 28. So 90 minus 28 is 62 degrees. Now I'm looking for DEC. Well, DEC is this angle down here. We're going to go back up to this top triangle we had here. 28 and 28 is 56. 56 from 180 gives us 124. So that is angle E, or angle at E in AEB. If I go the vertical angle to that, that is also 124, which is DEC. Next, we're going to look at N. Now, we're going to have to use the fact we have to know the perimeter of this rectangle, because these sides are not the same. If there are opposite sides, yeah, they'd be the same, not in this case. So, let's say, well, perimeter is 2 times the length plus 2 times the width. Our perimeter is 96, so that's equal to 2 times 6n minus 12 plus 2 times 2n plus 8. That gives us 96 equals 12n minus 24 plus 4n plus 16. Simplify that further, I get 12n and 4n is 16n, negative 24 and 16 is negative 8. I'm going to add 8 to both sides, and that gives me 104 equals 16n. I'm now going to divide 104 by 16, and I get that n is 6.5. Now, they want me to find BC. Well, BC is this value 2n plus 8. So to find BC, I'm going to say 2n plus 8. We found n, that was 6.5. So we substitute that in. 2 times 6.5 is 13. 13 plus 8 is 21. Now in 27, we're talking again about angles. So the sum of the measures of the interior angles of a 25-gon. Well, for a 25-gon, let's do our work over here. It is n minus 2 times 180, or 25 minus 2 times 180. That's 23 times 180, which we put in I'll put in my calculator here. 23 times 180 is 4,140 degrees. That is a lot of angles. But it makes sense. We have 23 angles, or 25 angles, because it's a 25-gon we're looking at. That's going to be a large total within those angles. And if you think as you get more and more angles, those angles get bigger and bigger. Now, the sum of the measures of the exterior angles. Well, going back to early in this review, the sum of the exterior is always the same. 360 degrees. So, gives us our value. 4,140 is interior. 360 is our exterior. Okay, now let's look at proving we have a rectangle. So if I plot the points I have L is 2, 1, M is 1, 4. N is 7, 6. And P is 8, 3. Now I could trace them in, but I'm just going to leave them as points right now. Yes, that is a rectangle, or that would be a shape maybe close to a rectangle. I could make it a quadrilateral, but I'm going to leave them separate just to help me identify as I go through and prove it. Now, what we know about a rectangle. It is a parallelogram. It's a parallelogram where all angles are congruent. So what I want to check is to see, first of all, maybe opposite sides are parallel. And if opposite sides are both the same slope and parallel, then the sets, let's say MNLP, they should match. MLNP, they should match. And then I can look at those respective slopes, and if they're opposite reciprocals of each other, that means they're perpendicular, which means I have right angles. So let's start with the slope of each line. So the slope of ML, and we could use slope formula here, but I'm just going to use that idea that change in y over change in x is slope. And we think, how did we change to get from M to L? So from M to L, I went down 3, right 1. My change in y was negative 3. My change in x was 1. My slope of the line I want to match up with it was NP. Well, from N to P, I went down 3, 1 to the right. So minus 3, positive 1. I can see that these are each the same. They're both negative 3. So I know that these two sides are parallel. Next, let's look at the slope of M to N. Should be an N there. Let's try it again. M to N, I go up 2 over 1, 2, 3, 4, 5, 6. So up 2, 6 to the right, that's 1/3. Now my slope of LP, I go up 2 and over 1, 2, 3, 4, 5, 6. So I find, in fact, that those two are parallel as well. So thus far, since ML is parallel to NP and MN is parallel to LP, I know I have at least a parallelogram. Because again, opposite sides are parallel. But that's not what it's asking for. It's asking for a rectangle. The way we know we have a rectangle is either all angles are congruent, or they're all right angles, or diagonals are congruent. Now, before I go off and look at the angles, realize since diagonals have to be congruent, I could theoretically look at the distance from M to P and the distance from L to N, use the distance formula, and see if it works out. We're not going to look at the diagonals. We're going to look to make sure we have right angles. Because again, if ML is perpendicular to LP, their slopes are opposite reciprocals. Oh, I just noticed an error here. Maybe I can make that 1/3. Almost missed that one. But again, if their slopes are perpendicular, or if they are perpendicular lines, their slopes are opposite reciprocals, or I can multiply the two slopes and get -1. Now, before I do that, I'm just going to write the slopes I have. -3 here, -3 here, 1/3, 1/3. So really, if I multiply any two next to each other, I'm essentially multiplying -3 and 1/3. Those are the slopes of any two sides next to each other. So if it's true that those are perpendicular, opposite reciprocals, or their product is -1, I know I have a rectangle. Well, -3 times 1/3 is -3 over 3, or -1. That tells me right angle, right angle, right angle, right angle. And LMNP is a rectangle. Our last one, 29, they give us the points, and now we need to find what fourth point will give us different parallelograms, but they indicate we need to go in certain quadrants. Now, review on our quadrants. 1, 2, 3, and 4 are our quadrants. 1 is in the positive for x and y. 2 is in the negative for x, positive for y. 3 is in the negative for both x and y, and 4 is in the positive for x, negative for y. Now really we could put all of these together on one graph and see all the points that go together, but this will break them down, so we have to specify by the quadrant. So we need first a parallelogram in quadrant 4, so we need to complete it here. Well, if I look, I went down 3 units to get to that point. I could do the same thing, go down 3 units to get to there, as well as I went over 3, and I could see, well, that would give me my 4th point here, which is over 4, down 4, 4, negative 4. Now, I could look at their slopes. I see I have horizontal lines and vertical lines. Parallel lines would give me, opposite sides being parallel, I should say, would give me a parallelogram. Now, I need quadrant 3. Okay, well I'm going to have to go somewhere over here. Well, if I notice, I went 3 to the left from this point to this one. If I do the same thing, I could go out here, and that would give me parallel and congruent lines, which would give me my point at negative 2, negative 4, which would give me a parallelogram. My last one, it has to be in quadrant 1, so that's up here. We're going to do the same idea we did in this one. I went up 3 to get to this point, and then go up 3 again to get to here. That gives me a parallelogram. That is at 4, 2, and I could show that that would be a parallelogram because one set of sides are both parallel and congruent, or I could look at all, or both sets of opposite sides being parallel and congruent.